Good day. This is Unit 10, Section 3 of Algebra 2. We're studying circles today. And in this review, we're classifying each conic as either parabola, circle, ellipse, or hyperbola. So when we have same sign, SIGN sign, that's they're both positive, and the same coefficient, we call that a circle. In the second one, both squared terms are two squared terms, so we know it's not a parabola. If there had been only one squared term, it would have been a parabola. But since it's two squared terms with the same sign but different coefficients, into what category do we place that conic? Please raise your hand if you think you know the answer on that one. So, yeah, Owen, go ahead.
Is it an ellipse?
It's an ellipse. When you got same signs but different coefficients, the conic is an ellipse. All right, so positive term, negative term. As soon as one's positive, one square term is positive, the other is negative, we immediately categorize that as a hyperbola. And oh my goodness, there's only one square term. So immediately we know that number 4 is what? Class?
Parabola.
Thank you, class. That was wonderful.
You're welcome.
Parabola. Class speaks. And here we got two squared terms. Signs are same. Are the coefficients same or different? Friends?
Same.
Same. So what is it?
Circle.
It's a circle. And followed by a parabola. And last one is another circle. So any questions on the warm-up activity? Just out of curiosity, how many of you got all 7 correct? It's like you nailed it. Got all 7. Several of you got all 7. Any questions on this one? All right, so the topic for today is circles. It's Circle Day, and the standard form for a circle, and please draw a picture of the types of circles we're talking about. We're talking about circles centered at the point H, comma, K. So instead of centering the circle at 0, comma, 0, we're going to shift the circle H units horizontally, could be either left or right, and K units vertically. So that's why the center is at the point H, comma, K. The radius of the circle is going to be designated with a lowercase r, and so the standard form of the equation is going to be x minus h quantity squared. Perfect square. It's going to come from the 3-box method, which is why the 3-box method was so heavily emphasized yesterday, plus y minus k quantity squared is equal to r squared. Now that is a child, in fact that represents all possible children of the circle x squared plus y squared equals r squared, which is a circle of radius r centered at the origin. So the parent circle, which is actually, it's a whole bunch of circles, an infinite number of circles with radius r centered at the origin. If you shifted h units to the right and k units up, where h and k are positive, then it's centered at h comma k. So once you have standard form, you know immediately what the center and the radius of the circle is. Like for example, I can inspect this equation and conclude that the center is at 2, comma 1 with a radius of 3. There's nothing to problem 1 other than plotting the point 2, comma 1 and going 3 units in all 4 directions. 3 units up, 1, 2, 3. 3 units to the right. 1, 2, 3 units down, and 1, 2, 3 units left. Draw the circle and you're done. So if you're in standard form, the center and the radius gives you everything you need to sketch the graph of the circle. Would you please attempt problem number 2 on your own? Document the center and the radius, and then sketch your graph. Yeah,
How do we get r equals 3?
well, see that, r squared?
Yeah.
This number is always r squared, so you just take the principal square root of that number over there. That'll give you the radius. So please try number 2 on your own. Doing an admirable job so far, by the way. Alrighty. Well, as far as the center and the radius goes, what are the coordinates of the center of the circle? Would you help me out, please? Alana.
-2, 3.
-2 comma, positive 3 is correct with a radius 2. So as long as you plot the point negative 2, comma 3, and in all 4 directions go 1, 2 units, you'll have the 4 points that you need to specify that circle. Raise your hand if you also came up with this particular circle on problem 2. You want to see where we're at? Now, if you believe that you're ready to go to the next page, we're going to do the thumb display. If you're in 3 seconds, if you want to go thumbs up, indicating to me that you're ready to go, do that. Otherwise, thumbs sideways or down. 3, 2, 1. Let's see those thumbs. Are we ready? Looks like we're ready to go. Best I can tell, let's go to page 2. Sometimes at this point of the lesson, you can gauge the pace of what's going on, and you figure out whether or not it's going to be one of those days where you get to work on homework during class,
True.
or whether, which one of these days, based on your gauging of how things are going. So,
I think we'll get class time to do our homework.
actually, I think you're right.
Oh.
Let's go on to page 2. So, all right.
I was scared.
A little bit of excess drama on that one. Now, example 1,
That's what you
I guess,
understand.
is what it says. It's example 1 of the new thing. What if it's not in standard form? So here is where we're going to put 4 blanks into the problem. And we're going to call this, please put your OE, you're going to need some space. Put it like not all the way over, but I think if you put your original equation code right there, you'll be in good shape. Because we're going to need 3 green boxes and another triplet of orange boxes. For instance, 6 boxes altogether. Here we go. Here's the setup. We got to complete the square in X and in Y. Why must we complete the square twice? Well, look at the standard form. We need a perfect square here and a perfect square there. So we need a triplet of boxes to pull this off and another triplet right over there. So here we go. Let's complete the square twice. The skeleton for this problem is x squared minus 4x plus blank, because we have to complete the square in X, plus y squared minus 6y plus blank equals negative 9 plus blank plus blank. Now, as we fill in the green triplet, which, by the way, who thinks they see what's coming for the green triplet of boxes? This is all part of the completing the square process. All right, well, okay, Andrew, have at it.
So we go in the first box, -4.
Andrew says -4 for the first box. You know what? I think he's got a good point, because that happens to be the linear coefficient of the x term. Keep going.
The next box is -2,
-2.
and then 4.
You got it. The triplet's -4, -2, and 4. So what that means is that in green, we're going to add the third box, which is 4, to both sides of the equation. Now, I've noticed that sometimes when I trick them, people enhance their notes with artistic accessories. If you want to be a little artistic on these notes, what you can do, just put a little fireworks explosion, when no one's looking, put a little State of Illinois, after all, put fireworks explosion on the second box, because that makes the next step, the factoring step, explosively fast. You'll be, as long as you use box 2, you'll be done with the factoring step in no time. So artists, have at it. Now, what's the second triplet of boxes going to be? Yeah, that's right. We got to complete the square in Y. Fill in your triplet right here. Fill in a triplet. All right, so Bethany, what's the first box in the orange triplet? Okay, do you see where we got the first box in the green triplet? It came from the linear coefficient of X. What's the linear coefficient on the Y portion? No, actually, it's going to be in this term.
Oh.
Yeah, the quadratic coefficient is 1, so put a -6 in there. What are the other 2 orange boxes going to be? Tom Skelch?
-3 and 9.
Yeah, so let's add 9 to both sides of the equation. So what we have so far is original equation, complete the square, and now we're going to factor using the explosive boxes, put another, when no one's looking, put an explosion, like a fireworks explosion around the second orange box also. All right, so for the factoring step, you don't really have to do anything other than the explosively fast stuff with box 2. x plus box 2 squared plus y plus the second orange box squared, which is a -3. Now, with your permission, I'm going to condense y plus -3 to y minus 3. Oh, hello. Well, good to see you again. So we have y minus 3 squared, and then over here we just simplify stuff that collapses to 4. Well, we have standard form. So we're ready to go center at 2, 3 with a radius of 2. Once you complete the square twice, it's like, wow, that was super fast. So now you see why it is we emphasize the 3-box method so heavily in yesterday's lesson. With a center at 2, 3, we've got a radius of 2. We're going out 2 in all 4 directions. And we've got it. We sketched the graph of that circle. We knew it was going to be a circle because we have 2 square terms, both positive and same coefficient. Same sign, same coefficient. Let's pause here. What questions do you have on how to locate the center, or how to identify the center and radius in this one? Anna?
Where'd you get 4?
This 4 right here? What I did was I simplified. It's actually a process that I like to call simplification. I took -9 plus 9 to get 0, and to 0 I added 4 to get 4.
What about, oh wait, okay.
See, this triplet factored into that.
Oh,
This
okay.
trinomial, I mean, there's a whole point of the 3-box method is to get a perfect square trinomial. All right, now, the thing that's just slightly different about the problem currently known as problem 5 is that when we set up the skeletal form of this, the form with the blanks, that's the skeletal form. So we got x squared plus 8x plus blank plus y squared minus 2y plus blank equals, we're just exporting the 8 to the other side. So it's going to be -8 plus blank plus blank. Would you please fill in all 6 boxes? Fireworks, explosion, artwork is optional. I know, you're like, Mr. Royce, what if I don't put fireworks on the test? You can't take off. If I could get away with it. Okay, well, Sophia, what's your first triplet?
Oh, that's square 4.
Triplet number 1, according to Sophia, is 8, 4, 16. Got it like that, so we're going to add 16 to both sides. And what's the other triplet? Help me out, please, Mia.
-2, -1, 1.
So, adding 1 to both sides. The fireworks explosions go on the second orange box and the second green box. What is the factored form of this equation going to be as you lean heavily on box number 2, green box number 2, and orange box number 2? Talk to me, please. Jay, you're on.
Would be x plus 4 for the first one squared.
Well, as a matter of fact, yes, it is. How did you do that so explosively fast, Jay?
It's the middle term. Put it in.
The exploding term?
Yeah,
Yeah. And then what's the rest of it? Just keep going.
and it would be y
Yeah.
minus 1.
Whew. You're blowing me away. And that's equal to, it's like, yeah, ease up on me a little bit. There's only so much I can take. Any questions on how to get the factored form? Class, finish it up, would ya? The center and the radius. All right. I know you're wondering, is it legal to be in that good of a mood? No, it's not. Just got to keep that on the DL. Sounds like a fuse. Any questions on example 5? No, the last one has a little bit of an oddity to it. We're not still on schedule, are we? Are we? We are. I want x squared. I want 2x squared. I want x squared and y squared. That's how this stuff works best. So, setting up the skeletal form, would you please divide both sides by 2? This is pre-skeletal form. So that way we've got x squared plus y squared minus 4y plus 3 is equal to 0. Then we're going to go to the 3 boxes. Now this time, there's no need to complete the square in x. You only complete the square in x when you have both a quadratic term and a linear term. We don't have a linear term in x. So we can hold off on the green boxes, and we're just going to complete the square in y. So it's going to be y squared minus 4y plus blank equals negative 3 plus blank. You're feeling like you're only doing half of a problem because there's only one triplet of orange boxes. Please fill in the triplet and then finish this one on your own. Sketch the graph of this circle. Triplets. Would you help me out, please? What is the triplet of numbers, Mason? Can you help me out?
I don't know.
Now, to find the first number, you look at the coefficient of the linear term. Now, in y, you've got a quadratic term, y squared. Its coefficient is 1. And you've got a linear term. What's its coefficient? Negative 4. And that's always the first number in the triplet. Now, can you tell me what the process is for finding the second number?
No.
It's always, what we did here was we cut the first number in half, and that's what you'll always do. 8, half of 8 is 4. Half of negative 2 is negative 1. It's even what we did, like, for example, this one. Half of negative 6 is negative 3. So what should the second number be?
Negative 2.
Yeah. And then can you describe the process for me to obtain the third number?
No, I wasn't here when you did.
All right, well, here, see if you can find the pattern. We took negative 2, it turned into 4. Negative 3 turned into 9. 4 turned into 16. You see what's happening every time? What's happening to the second box to get the number in the third box?
Square.
You're squaring it. Yeah, good. Good. So, what should this be?
4.
Yeah, so it's that third box that we add to both sides. So go ahead and try that. You have the third box to both sides. And then when we factor it, and would you help me with this one, please? Let's go with Anna. Would you tell me what the next line of mathematics should be?
X squared plus y minus 2 squared equals 1.
Boom. What's the center? Based on what you're seeing there, it's a standard form. I mean, you can think of x squared if you want as x minus 0 quantity squared. So, Jack, what are the coordinates of the center?
I'm not sure about the first one.
Think of x squared as x minus 0 squared,
Just be 0.
comma,
2.
yeah, that's it. Center's at 0, comma 2 with a radius of 1. So go to 0, comma 2, radius 1, and you're done. 1 and done. Any questions on today's lesson? No? Well, let's see. Wait a second. There's time to work on the homework.
Oh.
You're lying.
How did that happen? Now, in my first period class, students finished the homework in class, and they started asking things like, may we please turn in the homework today instead of having to wait until tomorrow to turn it out, or to turn it in? And to that question, my response was,
Yes.
okay. I said, okay. I didn't say yes, I acknowledged you. It's kind of like one of those whatever yeses as opposed to.
Whatever.
And then P's you have to,
Whatever.
All righty, well, thanks for coming today, and you can work on your homework.